everyone. I'm Cindy Runger, president of Seattle Rotary, and I'm happy to welcome you here today. So for those of you who are new to Rotary, there are 1.2 million of us around the world dedicated to leadership and service, and Seattle Rotary is one of the largest clubs in the world. This is the place where you can meet and hear from world-class speakers, make an impact locally and globally, and also meet a great network of professionals. And speaking of a great network of professionals, I have some fantastic news to share. So at the beginning of the year, I had asked you all to share with me good news so I can share it with the club. And so that's how we heard about Angie Holstrom's baby and also Laurel James' induction to the Wall of Honor. And so now, thanks to past President Jim McCurdy, we learned that Heather Fitzpatrick, where are you, Heather? Wave your hand, I saw you earlier. Yes, right there. So she has just been named CEO and president of one of our most treasured community partners, Wellspring Family Services. Congratulations, Heather and Wellspring. Yes. And so we have a lot of great things ahead today, including the Rotary Scholars Program and Dr. Iovino. Please all be seated for our inspiration with Joel Padgett.
All right, thank you. As some of you know, 9 years ago, I was diagnosed with lymphoma, a blood cancer throughout my whole body. I was given a 40% chance or less of living. And I'm here today clear of that cancer. So, please pray with me. Dear caring Creator, we are wonderfully and fearfully made in our mother's womb. But when we are diagnosed with cancer, we are full of gloom. CAT scans, PET scans, dog scans, MRIs galore, loss of white and red blood cells, nerve cells, and hair to our horror. Spinal punctures and 24-hour chemo for 20 weeks. People all around us from 1 to 96, a miracle to seek. Wondering why I am cured, why me, Lord, and why not her or him? It is by your grace and modern medicine we can sing the hymn. There is a balm in Gilead to make the wounded whole. May we lend our support until there is cancer no more. In your holy name we humbly and thankfully pray. Amen.
All right, and now I have the pleasure of introducing Vija Patel to talk about the Rotary Scholars Program. So many of you already know Vija. Vija volunteers tirelessly with several nonprofits. And in Rotary, she's past president of her own club, which is the Seattle International District Rotary Club, and has been assistant governor for 3 years, as well as chaired the Global Grant Scholarship Program. Professionally, she's been providing real estate services to the area for over 25 years. Her firm is Madison Avenue Realty. Her why does she do all of this so passionately and so tirelessly is what makes her effective. She immigrated to the U.S. as a small child from a village in India, population 500. The gift of having abundant food, clean water, shelter, education, opportunities is what propels her to want to make a difference. It's helped her family advance, and now with a large extended family in the U.S., many of them very successful, like Vija, they continue their mission of action and impact, leadership and service as a way of life. So Seattle 4 Rotarians, let's welcome Vija Patel.
Thank you, Cindy. So I have to say that I'm really excited to be here, especially while Cindy Runger is your president. That's pretty awesome to have a woman of color heading up this club, and then have another woman of color up here too saying stuff. So it's pretty exciting. Hello, Rotarians. I love being in Rotary because I find that I make fast friends in Rotary because we have so much that we want to do, which is for the common good, and I love that. So I'm here to speak about the Global Grant Scholarship Committee, and one of the great things about Rotary is that we have so many opportunities to volunteer and grow and lead and learn, and I appreciate all the opportunities that I've had to be a part of Rotary on the district level and learn about the programs that we have. So I wanted to just give you a little bit of an overview on the global grants. Through global grants, Rotarians can support future leaders in fields related to the areas of focus. And the scholarship opportunity was for a graduate level coursework or research scholarship for 1 or 2 years for an amount of up to $30,000 per year. A key feature of the scholarship offers partnership between local Rotary district and the district of the study location. The focus of the study is to be in the areas listed, which are peace and conflict resolution and prevention, disease prevention and treatment, water and sanitation, maternal health and child health, basic education and literacy, economic and community development. The Global Grant Scholarship Committee was involved with reviewing, interviewing, and selecting candidates that met the necessary guidelines. The caliber of candidates that we have been fortunate to connect with via the GGS program is truly impressive. You will be hearing from Dr. Iovino later today, and I'm happy to state that in addition to Dr. Iovino, we also were able to fund 3 Global Grant Scholarships to 3 very deserving women, and I'd like to tell you a little bit about those 3 women. I wish I had pictures of them, but Ms. Emily Koppel grew up in Indonesia and Vietnam for the first 18 years and was exposed to the pressing need for quality health care in marginalized and at-risk populations. Additional clinical experience in Sierra Leone and disaster relief work in Nepal shaped her worldview and commitment for delivering cross-cultural care. She says, "My ultimate goal is to work in a clinical setting advocating for increasing access to and improving quality health care systems that will enhance the livelihoods of displaced, migratory, or refugee populations." She is completing her master's degree at the London School of Hygiene and Tropical Medicine. She hopes to be working with Doctors Without Borders. Ms. Gretchen Duliner from Winville is attending University of Otago, New Zealand, which offers a multidiscipline approach for peace and conflict studies that is more inclusive of the discipline of development. She previously lived and taught high school biology and chemistry in Tinian Island in the Commonwealth of Northern Marian Islands, the CNMI. The CNMI is suing the U.S. military Marine Corps to prevent them from converting 2/3 of the Tinian Island and all of the Pagan Island into live fire ranges. Before that, she lived and worked in Papua New Guinea for over 4 years, working directly with indigenous landowners of the Papua people living in extremely remote areas with no electricity, where she utilized skills of conflict resolution, negotiation, and empathy from unique perspectives. Ms. Arakosh Faz Khazari completed her studies at the Fletcher School of Law and Diplomacy at Tufts University, studies in peace and conflict prevention, resolution. And I think you may be familiar with her because I know she's got a relationship here with this club. Arakosh grew up in war-torn Afghanistan, exposed to war and injustice under the Taliban regime. Having experienced the terrible injustices, she became an activist by volunteering to teach English, making internationally recognized film, by speaking up, and by building opportunities for other girls through helping build schools and writing trainings to prevent child marriage. She hopes to ensure a better life for future generations by being involved in Afghan parliament, and to not just be a symbolic, but for a real voice, to be a real voice in creating a better life for women and others. The program funds up to $30,000 per year, which is a sum of $15,000 from district and $15,000 from RI Global Match. Due to reduced foundation donations a few years ago, this district can no longer fund these at this time. We are asking clubs to continue supporting future deserving candidates via this program. One way to do this is to share in the raising of funds and making the project a multi-club endeavor. For example, 2 deserving candidates' master's programs could be funded if we had participation from 4 clubs putting in about $7,500. Like the candidates, we Rotarians are making a difference when we support individuals who are making contributions of their human capital to benefit the world. Oftentimes in the most difficult of arenas, important areas like peace, conflict issues, disease prevention, the people we are supporting via the GGS program are people who have a passion to do the work that very few others are willing to do. They make so many sacrifices so that the rest of us can be comfortable in our own lives. Not all of us have the opportunity to do these things, but we can support the people who have passion to stand up to issues and find ways to support vulnerable populations. By choosing to continue the Global Grant Scholarship program, you could be funding the next Jane Goodall or Margaret Mead. You are sending a message that people really can make a change through personal experiences. You are supporting grassroots endeavors. Some ways you can support the mission is to identify candidates in your own communities. Building partnerships in communities is what Rotarians and Rotary does so well, and we can continue to do that in the world by raising awareness and funds for dynamic individuals who are change makers and, like Rotarians, hoping to pursue their passions of changing the world for better. So thank you so much for listening, and please let me know if you have questions later on.
Thank you, Vija. That's what we're doing, the business of changing the world. Okay, and now to introduce our main program is Dr. Jarrod Dudakov. So Dr. Dudakov graduated with a PhD in immunology and stem cell biology from Monash University in Melbourne, Australia, and completed a postdoctoral fellowship in immunology program at Memorial Sloan Kettering Cancer Center in New York. In 2016, he moved to Seattle to establish his lab in the clinical research division at the Fred Hutch Cancer Research Center, where he is now an assistant member. He's also an affiliate assistant professor of immunology at the University of Washington. For his work, he holds, I don't know, like, is it up to 5 patents now? He kind of lost track, yeah. And received numerous awards, like having the rare distinction of having been twice a recipient of the American Society of Hematology Scholars Award, one of the organization's most prestigious awards. So with this pedigree, he's the only one that can come out to you and say, so you know the thymus is really a bit of a forgotten organ. Now, did you know that? I didn't know that. So anyway, please welcome Dr. Dudakov.
Thank you very much. Do we have a... So thank you very much for that. I'm going to introduce Dr. Lorenzo Iovino, who is part of my lab working as part of this Global Scholar Program. But I just wanted to give a bit of a background about what we do and why we do it. Anybody? Oh, here we go. All right. So what we're interested in is T cells, and T cells form a really fundamental part of the adaptive immune system. This is the part of the immune system that actually recognises either bacteria or viruses or virally infected cells and is able to actually get rid of those invading pathogens. Now, it does this in a very complicated sort of way, and really what it does is it recognises through this receptor on its surface known as the T cell receptor, TCR, it recognises these protein antigens that can be produced by bacteria or viruses or any other kind of pathogen, and these are presented by other cells. And when these T cells recognise these other cells, this is what activates an immune response, and the immune system is able to actually clear these pathogens. Now, there are innumerable type of these antigens, these proteins, little bits of chunks of protein that get presented by these cells. We don't actually know what they all are. There can just be any type of protein chopped up and presented. So we don't actually know what these antigens are, so we can't just design an immune system to recognise these unknown antigens. Now, the other complicated part is that the machinery inside the cell that actually chops up these proteins and then presents them onto the surface just will chop up every single protein within the cell. So in fact, most of the proteins that are presented on the surface of these cells are actually our own proteins. And only a very small number are coming from some sort of pathogen. And in fact, if we actually recognise these self-antigens, this is what leads to autoimmune disease, and this is obviously a very bad thing. So if we wanted to design an immune system, what we'd really want is to have this incredibly diverse T-cell receptor that can recognise all sorts of different antigens presented on the surface, but not recognising these self-antigens, our own proteins, so you don't get an autoimmune reaction. Now, all of this occurs in a forgotten organ known as the thymus, and this is an organ located just above the heart. It's probably more widely known in culinary circles as part of sweetbreads. This is what you eat in fine dining restaurants, but in fact it does actually have a really important part to play, and so really what it does is generates this really diverse array of T cells, but at the same time it educates those T cells not to recognise self-antigens, therefore trying to not cause an autoimmune reaction. But the problem is this isn't a static process, and in fact this function of the thymus actually declines with age, and that decline leads to a constriction of that repertoire. So now you've got fewer T cells there able to recognise that plethora of different antigens, and now you start getting holes in your immune system. And so now new pathogens can get through, cancer antigens can also get through, and this is, leads to an increased incidence of cancer with age, and this can obviously be a big problem. Now, there's a second problem as well in that the thymus is actually really sensitive to damage, and that can come in the form of things like just everyday stresses everyday insults like stress and infection, and as well as also more severe insults like chemotherapy and irradiation, these very common cancer therapies. And a consequence of that is that there's this very long delay in the recovery of the immune system after these very severe insults like chemotherapy and radiation. So there's a real need to develop therapies that can be used in the clinic to actually boost thymic function and boost T-cell recovery after transplant or in other cancer patients, or even just to improve the response about cancer. So a couple of years ago, I met Lorenzo at a conference, and he's got a very interesting background. So he's an MD, a clinician in Italy, but he's actually now also doing his PhD. And he'd found this very interesting clinical result, and he's going to talk about this in a minute, being that zinc supplementation can actually boost T-cell reconstitution after bone marrow transplant. But they really didn't understand much about the mechanisms about how that might be operating. And so with our background in this sort of T-cell reconstitution after transplant, Lorenzo approached me and asked to join my lab, and he has just been a fantastic addition to my lab. And Lorenzo is going to talk about this beautiful project that he's been working on for the past year and will continue when he gets back from Italy in January. So thank you, Lorenzo.
Thank you. Thank you, Jarrod, and hello everyone. And I'm very happy to be here today and talking about my project. I can say our project, and this project is supported by a Rotary Global Grant. And briefly, something about me. As you maybe can hear, I'm from Italy. I'm from Pisa. I graduated in Florence at medical school, and I received my fellowship in Pisa University Hospital. And it's a pleasure for me to introduce you my boss in Italy, Professor Mario Petrini. He is the director of our hematology division, and he's also the president of the medical school in Pisa University. And actually, he was also my first Rotarian contact. And after my fellowship, I decided to go and to this PhD program with the aim of studying the immune reconstitution after damage, after bone marrow transplant. We are a small bone marrow transplant center in Pisa. A little bit of background about bone marrow transplant. Why do we perform bone marrow transplant? We perform this procedure because there are many bone marrow diseases. Many of them are cancers. And as you can see in this cartoon, when these cancer cells grow into the bone marrow, which is the primary site of red blood cells, platelets, and white cells production, when these cells grow into the bone marrow, they cause a failure of this organ, and that leads to detrimental consequences for our patients. Those cells, the cancer cells of leukemias, as we can call them, they are both radiosensitive and chemosensitive. So we can kill these cells, but we should give the patients a very high dose of chemotherapy and radiation. And unfortunately, the outcome of the leukemia patients until the 60s was very, very, very poor, very bad. But the bone marrow transplant was discovered, was invented here in Seattle during the 60s and the 70s. This was the original bone marrow transplantation team at Hutch. In the middle, you can see Sir Edward Donald Thomas. On his left, you can see Dr. Rainer Storben. He's still working at the Hutch. He leads a lab. And this team of scientists discovered that it was possible not only to eradicate the cancer cells with chemotherapy and radiation, but also to substitute the old bone marrow with a new bone marrow from a healthy, matched individual. That was the concept of bone marrow transplant. And this discovery was amazing and helped thousands and thousands of persons all around the world. And that led to the awarding of Nobel Prize in Medicine in 1990 for Dr. Donald Thomas. Actually, he was the first of the 3 Nobel laureates of the Hutch. So, bone marrow transplant is very important. We can cure patients, but it's a big procedure and it's a big risk. And patients still die of complications after transplant. Briefly here, you can see that after allogenic transplants, that means transplant from an external donor, you have a high rate, we can say a high rate of mortality due to the relapse of the primary disease. In the first 12 months, it's the higher percentage of relapse. And you have also a high rate of infections due to immune dysfunction after all these damages. And we can also say there is a third part called GVHD, graft versus host disease. And we can say that more than 50% of the causes of death after transplant are related to a dysfunction of the immune system. So they're due to a bad immune reconstitution. And just to have an idea, these are the numbers. And we are transplanting more and more patients. And these patients are older and older because clinicians are able now to do transplant until 70 years old. That was unbelievable 20 years ago. But as Jarrod said, the immune system is more damaged and it's aged because of the aging. The thymus has this remarkable capacity for regeneration. We know that we need thymus to have a better reconstitution. As you can see here, both in the mouse model and in the human model, you have a sharp reduction of the thymic size and the thymic function after an acute damage. That happens in mouse and human, but after this, you have a recovery of this function. So the thymus itself is able to regenerate. But even this beautiful capacity diminishes with age. Look at the comparison between a 23 years old young boy and a 3 years old kid. We can say that a 23 years old boy is old. But of course, But look, there is a difference between 3 years old and 23 years old. So that means that this difference, this pre-transplant difference of the thymic function matters. And there is this beautiful study of a couple of years ago demonstrating that a higher thymic function before transplant, TREX, it's a way to measure the thymic function in patients. This study demonstrates that having more TREX, so more thymic function before transplant, impacts dramatically on the survival of the patients after transplant. You can see here, 60 months after transplant, more than 80% of the patients with a good thymic function were alive. And look here, if the thymic function was poor before transplant, the mortality rate is much higher. So we know that thymic function has a profound influence on clinical outcome following transplant. Can we develop methods to boost thymic function in recipients of hematopoietic stem cell transplantation? That was the question, and this question led me here. And as Jarrod said, we've known a couple of years ago. And when Professor Petrini, my director, my boss in Italy, told me about the chance to apply for a Rotary Global Grant, I had no doubts. And I said, okay, if I get this grant, I want to go in Jarrod's lab and study the thymic reconstitution. And briefly, this is the timeline of my global grant. It started 1.5 years ago, and I had my first contacts with the local local Rotary clubs near Pisa. And they were the promoters of this global grant to Rotary International. And I had my first contact with Rotary International in May 2017, and finally 1 year ago I arrived here. And I have to say thanks to Dr. Derek Pasternak, who helped me from the very first day here. Basically, our idea was that zinc supplementation could help the thymic reconstitution and the immune reconstitution after transplant. We have 3 good points, I think. First, zinc deficiency, unfortunately, is a big problem worldwide, and it affects more than 2 billion people. And we know very well, because of this, that zinc deficiency causes immune deficiency and thymic aplasia. That means that in these patients, it's impossible to see a functional thymus. But both of these effects are reversible after zinc supplementation. We know that zinc plays a role on thymic function and immune function. And there are beautiful studies demonstrating that a mild zinc deficiency could be partially responsible for thymic aging and poor thymic function in elderly. For this reason, we performed in Italy at Pisa University Hospital a clinical trial on patients receiving bone marrow transplant. They were 65 up to 70 years old patients, so medicine calls these patients as aged elderly. And we found these results. We measured the thymic function after transplant, and we enrolled patients, half in a cohort of patients receiving a zinc supplementation for 100 days after transplant, and we compared these patients to the standard of care of the other transplant patients. And as you can see here, we measured the thymic function in these patients in several ways, but we found an interesting increase in the thymic production of new T lymphocytes in the zinc-treated group. We didn't know about the mechanism because there is evidence, but we didn't know about the mechanism. And here in Jarrod's lab, we used a mouse model of thymic damage and bone marrow transplant trying to find a mechanism of the zinc action on thymic function. Basically, we used 2 models. One was called sublethal irradiation, total body irradiation, or TBI, which basically was a single dose of radiation that is able to cause a damage of the thymus in these young mice. And we also use another model of bone marrow transplant in mice with a lethal dose of radiations, followed by the injection of bone marrow derived hematopoietic stem cells from an allogenic donor. And as you can see here, we harvested the thymi of this mice 3 days, 7 days, 14 days, 28 days, 42 days after transplant, and we compared a group of mice that received zinc supplemented water and normal control mice that received only radiation or only bone marrow transplant. And as you can see here, the red bars, we found an increase of global thymic cellularity at all the time points in both models. So first, we confirmed that there is an effect, a global effect of zinc on thymus. We know that after damage, thymus is damaged and many cells die, but after this, there are radioresistant cells which are able to release factors for the regeneration of the other cells. And we focused our attention on the endothelial cells, which are the cells inside the blood vessels. And we know that these cells play a role in releasing regenerative factors. One of these factors is called BMP4, and we recently published a paper about it. We measured the level, the number of endothelial cells after damage, and we found that we have a higher number of these cells in the zinc-treated mice. So maybe that could mean that zinc acts on this kind of radioresistant cells. And we also found a higher rate, a higher proportion of thymic epithelial cells, TECs, proliferating in the zinc group. And we know that there is this axis between BMP4 and thymic epithelial cells because 10 days after radiation, we have the highest levels of BMP4 in thymus. If we do a deletion of the gene of BMP4, we have a worse thymic reconstitution. That means that BMP4 is very important. And the target of BMP4, endothelial cell-derived BMP4, are the thymic epithelial cells, the TECs. So we hypothesized that the mechanism could be an increase of BMP4 production from endothelial cells. We measured the BMP4 production in the zinc-treated mice, and we found at day 10, where we expected to see the peak of production of BMP4, we observed this higher content of BMP4 in the thymi of the zinc-treated mice. And we confirmed that with 2 different kind of assays that we use for proteins. Then we tried to treat endothelial cells in culture, so in vitro, just plating the cells, and we put them in contact for 24 hours with zinc salts, and we observed that these endothelial cells in vitro produce more BMP4 after zinc exposure. So this could be the mechanism. And because of this, we thought that the extracellular zinc could be involved in this signaling. And we know that there is a receptor on the surface of many cells called GPR39, which is called also zinc receptor, which is able to translate extracellular zinc signals into intracellular signals. And we demonstrated that this receptor is expressed on the surface of thymic endothelial cells. And we also measured the levels of extracellular zinc after damage in mice that didn't receive any zinc supplementation. And actually, we found that after damage in the thymic extracellular fluid, we have more zinc. Maybe we still don't know about that. Maybe this zinc comes from the dead cells. And the expression of this receptor, this zinc receptor, is increased in a spontaneous way at day 4 and day 7 after damage. So maybe this could be one of the likely mechanisms in which zinc is involved in the thymic function. Maybe zinc could trigger the release of BMP4 from endothelial cells, and in this way, this can promote the regrowth of the organ and the regrowth of the epithelial cells. We hope that in this way we could achieve a better understanding of these processes to be translated into the clinical practice to decrease the rate of mortality due to worse immune function. these are my acknowledgements. First of all, I have to thank Jarrod for his mentorship and for having me for this year. And I have to thank you for inviting me. I have to say thank to Rotary International and to Pisa Hematology Division. And I'm happy to answer to your questions. Thank you so much again.
A question from Sue here on your left.
Hi. Oh, hi. Hello.
Hello.
I have a question for all of us. If we took zinc supplements, would that be helpful? Well, you know, you can just buy them in the health food store, right? Right. And how much would you recommend?
That's a very good point. So, when I started studying zinc, the first thing that I discovered, that I found out, was that in the United States, there is a big zinc consumption. Zinc is everywhere. All the tabs against, against cold, the common cold, against flu. And actually, there are scientific papers showing that zinc supplementation could reduce the length of a common cold of 1-2 days. So we used a very high dose in our patients, and that is questionable. But we wanted to use zinc in that particular subset, and we did the same on mice. We got the approval of all the ethical committees. We have no troubles with severe adverse events. I have to say that. It's not clear yet what is the best way to supplement zinc. Someone says high dose for short periods in the normal life of an individual, not after transplant, of course, or a small supplementation every day. The problem is that in elderly, you have conditions of, sometimes you have difficulty in eating, or people with a very, very low income, people that are losing their teeth, and in that condition, you should receive a higher dose of zinc, because the zinc deficiency is, in that case, is sure. But I have no recommendations about the zinc dose. The zinc intake, the recommended zinc intake should be at least 12 mg every day. That's not that easy to reach, because zinc is labile, and you can absorb less than 50% of zinc in food, and you should eat oyster every day to have that dose, because oysters are the food with the highest content of zinc. So hopefully we will have an answer soon about this. But the recommendation for zinc tabs during common cold and flu is it's a good recommendation, I think. That's not a recommendation from me. I know you use it. Other questions?
As I go over, three different people that had their hands up had the same question about, is there a zinc pill? And then another person had 2 additional questions, and you answered both of them during your answer. So great job. Here we go. Here's one right here.
Do you take a zinc supplement?
Yes. Okay. I should say, I don't want to mention the brand of the zinc pills that we have only one vendor in Italy, and I have no choice. Here in the United States, I use 2 pills a day for 30 consecutive days, 1 month on and 3 months off. That's my personal schedule of zinc plus quercetin.
Okay, we have Anne.
Hi there. I'm Ann Gillingham. I work for the Leukemia and Lymphoma Society, so this is very interesting to me. Number 1, I hope we can help fund you in the future. And number 2, how much time, or what is the next piece of your research project to get it to this discovery, if it really meets all of the metrics needed to go to patients? How much longer will it take to be recommended as a part of someone's treatment?
Okay, we published the first paper about the pilot trial, and the pilot trial in Italy is open. So we're still recruiting patients to this clinical trial, and the drug is safe. But we're having troubles because the only industry that gave us the zinc pills for the study has failed 1 year ago. And we have to find, now I'll go back to Italy and I'll try to find a way to continue the study, but the drug is different, so it could be a problem. We found no adverse events. Basically, now the idea is to find a strong mechanism demonstrating that zinc is safe and effective. And after this, I think that we could publish a first paper about it, and we could think about a clinical trial in the allogenic transplant setting in the future. I think here in Seattle, we will be in the best place to do that. This is the first center, transplant center in the nation, in the country, so hopefully soon.
Here on your left.
Hi. Hi. Oh. Hi, my name is Ashok Ingley. I'm actually new to this environment, so pardon me. Had a question. If I understood it correctly, I thought you were saying that the effectiveness decays substantially with age of the individual. Is there a way to combat that so that the effectiveness for someone that's a younger person like me would benefit as much as a 1-year-old?
That's a big question. That's a big question. I think we know several pathways of thymic aging. We know that several factors play a role, and we can say that the environmental stress and high levels of stress hormones could negatively affect the immune function. So the prevention of this kind of aging of the immune system could be done preventing the stress-related factors. But about thymic reconstitution, we know other factors, and we know that, for instance, and this is a beautiful paper from Jarrod, and we know that after the puberty, the thymic function starts to decline. So maybe, not maybe, for sure now, sex hormones play a role, but we can't get rid of sex hormones in everyone just because. But this is interesting because in dramatic conditions we could use a selective block of that mechanism to improve the thymic reconstitution. I have no answer for that. Last question. Derek.
Yes, I'm certainly glad to have played a small role in bringing you here, Lorenzo. Now that you're going back to Italy, number one, what is your next professional plan? And secondly, are you going to join Rotary Club in Italy?
So I have to finish my PhD in Italy now, and it should be in late 2019. And about Rotary, I have a lot of Rotary friends in Italy. They're always trying to push me to the closer Rotary Club, and I'll be in contact with them. So, okay.
So today, I will leave you with a quote, which has been attributed to many different people, but for today, in honor of our guest speaker who is Italian, it's Italian. So in honor of Dr. Iovino, his journey to America and path to scientific discovery. So Dr. Iovino, can you say this in Italian?
Hi. So, thank you. Il successo non è definitivo, il fallimento non è fatale, il coraggio di andare avanti è ciò che conta.
Ooh, yes. So, in English, success is not final, failure is not fatal, it is the courage to continue that counts. It's been fun, everyone. See you next week. We're adjourned.